Finally got this chat working on X. So if you're watching live, I think YouTube will also send the chat to me, but I will be looking. So feel free to drop a comment. All right. I'm just 1 second. I'm just gonna verify that it's live. It is. Okay, cool. Great. Thanks for tuning in today. So last time we did this, I thought this was the best stream that I've done so far, this diving into AI one. I go in it, I talk about what neural networks are doing beneath the surface, and I get into all the most important pieces of Andrej Karpathy's talk about software 2.0. And in this stream, we're going to finish reacting to that video. We're going to finish talking about software 2.0. And we're finally going to start to get to some crypto stuff. So we're going to tie this into crypto. And I thought it would be fun to compare the crypto industry and the AI industry and see, let's put them head to head and let's see who actually comes out on top. So first, what I want to do is I want to encourage everyone after this video will stand alone. You don't need to watch this, but I really recommend, I think this is my best stream. So please check this out when you have time. You can look at my YouTube channel, LZRS CG on YouTube. And it's in my X feed as well. So you can go and look at my history and watch this later. But I will give you a summary of the stuff that we covered in that last video. So here I have this sources playlist on my channel, and this is going to contain the videos that we're reacting to. So I'm going to go back and we're going to start reacting to this talk by Andrej Karpathy. We're going to start in the middle. So that we can finish from what we did last time. So first, I want to give you a summary of what he said, and I'm not going to give you the whole summary of the whole video, and I recommend check this out on your own time as well. This is a very good video, it stands alone. But I want to tell you the parts that are going to be important for the discussion that we are going to have today. So basically, Andrej Karpathy is an amazing AI educator and an engineer and manager, and he worked previously at OpenAI, but before that he ran self-driving at Tesla. So he was the one who really got them on the right track. And I mean, there's a lot of great people on that team. I'm not trying to give him all the credit. Elon has said he's not the only one who deserves credit, but he is a great mind, and the way he thinks about this is revolutionary. And I'm gonna explain to you why. But basically, he worked at Tesla. He started pushing them in this direction instead of doing a lot of manual coding where they implement the rules of self-driving by hand. He got them to have a much more automated system. So I'll talk about this. So basically, he's talking about the history of computing here. And his basic idea is that in normal computer science, in normal programming, when you're making software, normally what you do is you understand the problem, you fully understand the problem, and then you write code to implement the solution. So in order to do this, in order to make traditional software, what he calls software 1.0, in order to do this, what you do is you break it down, and every single step, as an engineer, you write the code that tells each instruction to the computer to do this. And in order to do that, you need to actually fully understand the problem and fully understand how to achieve the thing that you're trying to build. So for example, a social network where you're sending a message from this user to another user, this is something that you can build with software 1.0 because you know if this user types in this data, you transfer this data to this destination, you route it using this routing algorithm. There's all these things that go into this that are understandable by humans. And that is what we have been able to build using software 1.0. And basically, though, he calls this an approach by decomposition. You understand the problem, you decompose it into steps, and you have code that represents that. So what he's going to do in this talk is he is going to walk through what is called software 2.0, which is where you are not able to decompose the problem. So this, as he said, this is something that has been very productive. All the software you're using today, engineers who understood the problem and decomposed it and wrote every single line themselves. That's crazy. If you think about it, that's crazy. And so we have done so much with that. And we're going to get back to that, and we're going to get back to the mechanisms that allowed us to do that. But there are limitations to this approach. And so what he talks about is that, for example, image recognition is very hard. There's no way that you can create an algorithm yourself that will actually recognize a cat, because there's so many diverse pictures of cats. Let's go like to this picture here, like all these pictures. I mean, these are all so different. If you tried to break this down into steps and you wanted to get very granular at the level at which the computer can understand these instructions, you would not be able to describe what a cat looks like to a computer. It's just too complex. And he kind of walks us through the history of AI. And basically, at one point, it was just all written by hand. And you would just look for certain things. And if that condition was met, then you could make a certain classification on an image. And it was basically super ineffective. But I will show you an example later of that actually doing some cool stuff. But for the most part, in the 80s, AI was next to useless. It was conceptually interesting, but it was almost useless. Then we started basically getting to be able to automate some of these things. So instead of detecting things by hand and having these heuristics to make these seemingly intelligent systems, we were able to use different types of statistics and neural networks to sometimes, not fully do all that ourselves and kind of automate some of that. So maybe you could have some kind of thing that could detect edges really well. And then from that, you can run some additional logic on it, or probabilistically, do some kind of do some kind of thing. And I'm not an expert on the history of how people used to do AI or anything like that. But the point is that over time, more of this got automated. And so in the 90s, there was like handwriting recognition and some other things that were interesting, that were very useful, but it still was very limited in what AI could do. And as he says, this kind of continued to the 2010s. And over time, again, these systems got more capable, but they still were. I mean, remember back to 2010, AI was not a big trend at the time. In some circles it was, but it wasn't really impacting people's lives very much. Like as of now, I mean, ChatGPT is taking over. They just announced O3. It's like blowing out these benchmarks. Everyone's investing. NVIDIA is to the moon. That was not the case in 2010. And so. But the point is, it was more odd. They were able to use neural networks to learn certain things, but there still was a ton of manual work that they had to do to piece these things together to make it work. But what they started realizing, and this was 6 years ago that he gave this talk. So, all these lessons were learned since that. So it's what, 2023. So this was 2017 that this came out. This is actually around the same time that Attention Is All You Need was published. But even before that, people were realizing that over time, this manual work of creating these features could be automated by just adding more compute and data and scaling up the training. So let's just show this. Basically, this is the perfect thing. This is a timeline. First, they were hand-coded everything. Then they started having some linear classifiers on certain features. Then they had convolutional neural networks, which is a much more automated way of extracting features and feeding it into the neural network. And then they have this basically an even more hands-off approach to training AI. And so over time, as he says, on this axis, there is less design and needed. You write much less code, you do much less work actually implementing the AI. And as long as you're able to scale compute and data, you actually end up getting better results. So the best performing models, as you add more compute, they do way better and you're designing them less. So this is what's really cool. So at Tesla, basically, I'm going to come back to this because this is really important, but I'm going to come back to this for a sec. I'm not going to get into all these things that he's saying, is that basically they originally had a lot of 1.0 code. at Tesla. And so there's 1.0 code, which is stuff that they manually wrote. And then there's 2.0 code, which is stuff that they learned through neural networks and training and stuff. So so you can imagine, like, let's say you're trying to build a self-driving car and you can detect the edges of the road. So you detect the edges of the road, and then from that you could calculate the distance manually, saying stay in this far from this lane and this far, like calculate the midpoint and then stay there. And you could think of all these things. Or let's say you saw a car was stopping in front of you. You want to maintain a certain distance. So if you see that distance is closing, you go at a slower speed or something like that, right? So you can imagine all the types of things that you can hard code into a self-driving car algorithm. You're not going to be able to do everything, but there's going to be a lot of things that you can. And I'm going to show you some cool examples of this later. But point is, that is not very effective. And honestly, Tesla self-driving used to not be very good. It honestly wasn't very good. It was kind of a scam. Actually, there's huge controversy over the fact that Elon was marketing it. And but believe me, I love Elon. So no, I mean, he's a visionary. He knows what's going to happen in the future, and he's making it happen. But at the time, when he rolled out Autopilot and when he was touting how soon this stuff was, he, in a sense, overpromised. And people thought, okay, it's going to be self-driving. They tried it, and it just didn't do a very good job. But now, when you try it, it's very, very good. I really recommend anyone who hasn't tried self-driving in a Tesla, try it again. It is so good. It is so freaking good. And the reason is basically this, and this laid out how they were going to get there before they actually did, because this was 6 years ago. So this is the new, at this time, how he represented where they were at. So before, the 2.0 code was this small little section of all the code. And now he's saying, look, 2.0 is eating 1.0. And I think if you extrapolate this now almost a decade later, I bet this blue is most of it, and the pink is a very small section. And this is something that George Haas also talked about, that he predicted that eventually Tesla was going to basically be completely trained end to end with very little, very little human intervention. Okay, but let's go back, because we skipped over some part that was the most important part of this entire talk. What we talked was, this is what's important. So one thing I want to illustrate, I want to communicate that basically software, you can think of software as also what a neural network is. A neural network is a piece of software. So in traditional software, you are writing code manually and you're transforming inputs into outputs. And that's really all it is. Like, you can look at lambda calculus, you can study computer science and see how everything is essentially a function. That's one valid way of looking at it. It's a completely, entirely valid way of looking at it, is that everything is a function, something that takes an input and transforms it into an output. And that's also what a neural network is. So a neural network, as we discussed in the last video, we go into all this theory at the last video, but basically you have this thing called perception space. And or input space, and there's data fed into this space, and the neural network actually transforms those inputs into something that is into an area within what's called concept space, and that's how it classifies it. And so essentially, it's just a function that runs a transformation on data. But what that does is it actually creates really powerful software. Software that is so powerful that you would never be able to code it. So let's give an example of ChatGPT. ChatGPT, essentially, it's taking in the previous text as an input. That's the perception. And then it transforms that into it transforms that data to some place in concept space. And that would be the next word. And that's how it decides the next word. So based on the input, now it's mapped that input into an output, which is the next word, and it just keeps doing this. And so that's how it generates each word of the text. So this is a super powerful thing. But imagine if you were going to write by hand without any AI, an algorithm that would be able to answer any question and give high quality answers. You wouldn't. People have tried this for decades. It doesn't work. It's not possible. I mean, how could you, you can ask the most obscure things and get an instant, amazing response from AI. How could you possibly write an algorithm that does that by hand? You can't. It's just too hard. And that's why you need software 2.0 to do this, because software 2.0 can make things that software 1.0 can't. So let me illustrate this. So let's think of a very simple program. Hello world. That's what every beginner programmer learns. Hello world. So hello world is it's just simple. So that would be in the middle of the circle. Now this circle represents all possible software, all possible programs. So anything like x.com, YouTube is over here, whatever. Like you can think of anything that you ever use. The calculator app is over here. Like every single thing, your side project is in this conceptual circle that contains all possible programs that can be run on your computer. And so a very simple thing will be in the middle. Now, as you go out, this is more increasingly complicated software. So like one example of something that might be complicated is Google search. That's pretty complicated. So it takes a lot of technical knowledge to know how to implement that. And essentially, they got tons of really good engineers, an organization. It's not just one person. It's an entire organization, huge budgets, tons of research, and the best and brightest in the industry. All these people are working on this one piece of software 1.0. I mean, there's some AI in there too, but let's just call it software 1.0. They're all building this complicated system, and so it's somewhere in the circle. It's not in the center. It's complex, but there is more complex software, such as whatever would be out here in this space. So there is a limit on the information retrieval software that humans can code themselves. And that probably is similar to what Google search is. That's probably the best thing that humans can do themselves. But let's say you want something that can answer any question with high quality response instantly. That's going to be more complicated. It's going to be so complex that no person and no organization could come together and build it. And but you can do it though, if you don't do it through decomposition, which is understanding the problem, like understanding how to answer every single question possible. How do you understand that? How do you decompose that? You can't. Instead, you got to use software 2.0. And so what this does is it searches for the result. So you start here with perhaps a really bad answering machine, something that just gives bad answers, but you adjust it and you adjust the implementation, and who knows where it ends up. But now this is going to be a very high quality product by the end. You optimize its efficacy, and in doing so, you search for the implementation of the software that does the job really well, and that is software 2.0. So in software 2.0, what you're doing is, instead of this old approach that we used to do, where we would just break down the problem as much as we could, and we basically for really hard problems, we don't get good results. Instead, with software 2.0, we just take a step back and we don't do anything. We just feed it data and compute. So you need high quality data, and you need a lot of compute, because basically what you're doing is you're running backpropagation, which goes and it finds the mistake that it made, and it goes backwards and corrects it, and encodes that into the neural network. And we talked about backpropagation and gradient descent. You're able to make really powerful software, but this isn't something that you can necessarily do on your laptop. You can for something like handwriting, because that's not that hard. But for something like ChatGPT, you need data centers to train this. That's how much compute is going into it. And when you're training it, you're just brute forcing this, basically. You're just giving it more data, seeing where it got it wrong, you're adjusting it. You're doing it so many times until finally, after you have hit an astronomically high, immense scale of adjustments got adjusted, and all the weights of the neural networks have been adjusted a million, trillion, bajillion times over, and you have billions of parameters within the model, and they've all been adjusted an unthinkably high number of times. At some point, if you do that enough times, you can have a really effective piece of software that you would never have been able to make yourself. And so that's software 2.0 I'll talk about today. But I want to finish just the reaction so we can close the loop on that. Basically what he was talking about for the rest of this so far is he's just talking about the practical challenges and considerations when you're actually doing software 2.0. So he was talking about how hard it is to label things and just the edge cases and just really funny things that they ran into when they were actually doing this businesses. So let's just go through this starting here. Let's just go through and just, I'm probably not gonna interject that much, but I want to just cover this finish. Let's do it.
You bring it to an environment that looks different, that's not going to work very well. So either in this kind of environment or even in San Francisco where the roads do weird things, that might look foreign. And so now you need quite a bit of data to actually have a coverage and have a broad distribution. The other thing I didn't appreciate is just how iterative the labeling process is. In academia, I was just giving ImageNet, that's done, but you can't annotate a data set and be done with it. That's not something that happens. As an example, we have this auto wiper feature. Normally you'd use a sensor, but Elon looked at some of these windshield images and he's like, well, we can see raindrops, so we can just use that. And now it's my problem. So the problem now is we have a windshield and we're looking out with a camera and we're trying to just detect if there are raindrops there. And you might think this is pretty straightforward. We just collect some data, we train the model, we try to deploy it, and this completely breaks. It breaks in all the kind of rare situations, and that's the problem, is, if there's ice on the windshield, there's dust. The auto wiper, the initial result of it, when we trained the first time, was extremely excited about tunnels. The wipers would just go like mad inside tunnels, and when sun is in the view. So now what you have to do is you have to now massage your training set. So suddenly I need a lot more tunnels, and I need to make sure that the network knows that you should not be turning on inside tunnels. And now I need to add that. I need to have enough of it in the data set and worry about it. But if you do your job well, this actually works somewhat. We've shipped it. It works to a decent amount. We're still improving it. It definitely wipes when there's a lot of water in the windshield. In fact, it wipes even if you put cornflakes on there. According to this video called Will It Wipe? Cornflakes wipe, ketchup does not wipe. So that's cool.
It seems like a major oversight. If you're getting ketchup on your windshield, you definitely want to wipe it.
So I think my kind of takeaway from being at Tesla for a year and trying to really apply this technology is this is a whole new way of designing software, and we need tooling for it. We've been writing the 1.0 software for a long time, and we've written out IDE. For example, we have IDEs that help us write code. So, we have pretty fancy programs that do, highlight, syntax highlighting, go to definition, debuggers, profilers, infrastructure for helping you write code. But now, instead of writing the code explicitly, we're accumulating and massaging the data sets, and those are effectively the code because they are compiled by the optimization into code. So your data set is really the code. And what are the IDEs for data sets? And so we have some of our own answers to this.
So let's just to make sure you got what he's saying. He's saying that the data set is essentially the code. I mean, that's the IP that you're using, along with some minimal amounts of code to actually construct the neural network and the architecture and all that. And there's probably a good amount of actual engineering, data engineering that goes into making a super high performance system. So not to like diminish the amazing work that those engineers are doing and those teams are doing, but the main thing, though, is that you want to have a high-quality data set. And with that, when you have that data set, then assuming you have the compute, you can compare those two to get those amazing results. And so what he's saying is that instead of having an IDE to write this code explicitly for whatever this complex task you're trying to do is, instead, we need to think about what is the tooling for generating the data set and structuring it properly and annotating it and ensuring the quality and doing all these things. Like, what is that tool set? That's a super underdeveloped thing. At least it was in 2017 when he was saying this, or I guess this is 2018. Now I'm saying this right here. So, go figure. Yeah, so anyway, let's keep watching and see what he thinks about 2.0 IDEs.
And we're still trying to develop it, and I'm not going to flash the exact interfaces, but just to give you an idea on a high level, some of the things we find very useful is around visualizing data sets, of course, making sure that you have a very broad distribution, that you want to look at the label distribution, or getting a sense of what's in, designing what feels like a Photoshop, really, for data annotation, because these software 2.0 workers, this is their full-time job, is to label data, and you really want to make them power users, and you want to get them to work really efficiently. And it's not just about the annotation itself, it's usually you have a workforce, and so now you need to make sure that when a labeler is confused, they don't just do something random, they need to be able to escalate a feature, escalate some kind of an image when they're confused, and you need to resolve that later. Or you need to flag disagreements between them. You need to make sure that they're performing well, and you of course want to potentially have a layer of AI kind of helping them out. Like they're programming, you have to do your best to help them out. As one example of something we also found pretty useful, just to give you ideas of the workflows, for cleaning the data sets, the layer of AI that can help you with that is that your networks can actually like tell when a label for an image looks suspicious. So for example, if you're annotating lane lines, that one on the very left will have a small loss because the network is like, oh yeah, that's right. But if you annotate a lane line in the sky by accident by one of the workers, the network can actually bubble it up and say, well, that looks weird. I would mispredict a lot on that. So we can create these clean data sets, and we can help out the labelers to find the mistakes in the data. This is not only due to mistakes, by the way, but if we change the annotation instructions, which we do quite often, then when you change your labeling documentation, then suddenly lots of your data is suddenly mislabeled effectively, and you need to come back and you need to fix it. The other thing we worry about a lot about is normally in a setting where you have a lot of labeled data, but then you have even more unlabeled data. In our case, we have the fleet. We have actually infinite data. The problem is not how do I train on my infinite data. The problem is how do I pick and choose intelligently what I should label, because I have to pay for that labeling. What are the examples worth labeling? And of course, it's things like where your network is uncertain or mispredicts. And how do you bubble those up? And how do you show them to the labelers and show them that actually the network does mispredict here? And so you end up with what I...
That's really interesting that they consider themselves, at least at this time, that they had too much data, or at least virtually unlimited data. And so they didn't even need more driving footage, I guess, according to them. Really, it's just the fact that they were not able to parse this data past that and basically do just basically feed raw footage into the machine learning algorithm and have it kind of extract all of its own features internally and just do a fully end-to-end thing. I know that that's the direction that they're going. This is something that they've talked about and that like George Hotz has highlighted. I think I mentioned that earlier in the string, but I wonder how far along they actually are in that. And I wonder if they, at this point, are effectively using all the driving data that they have or not. That's something that I'd be interested to know the answer to.
I refer to as kind of like a data engine, where to fix these problems, you actually end up combining a number of things. We want to train, retrain, and redeploy. And we spin this data engine for all the tasks, for all the cameras. And the nice benefit of this is that the programmers are not addressing all the edge cases themselves. You've made all the problems look the same way, because now you just turn the data crank on all of it, and it's much easier to accumulate these data sets and have all of the infrastructure for all the problems, and then actually writing the explicit code in all the things that fail. And so we made all the problems kind of look the same with this approach, and then we just train the networks and we ship them and we just massage those data sets. And if we can do our job very well, then we'll be able to get this beautiful robot to drive nicely, and then more people will buy Tesla vehicles, and then the future will be a good place on, on Earth and beyond. And so if you'd like to, if you're really excited about the software 2.0 stack and want to push it to its limit, then please reach out. We need a lot more help building out the entire stack and the whole infrastructure. Okay, thank you.
Awesome. Yeah, what a great talk. So I want to just come back to this point because this is just so important. This is a search problem. You're searching for the best implementation of this software. And so normally you would just write this one by hand, this 1.0. It would be as complex as you could handle, but it's not going to be that complex because there's just a limitation on human capability. But with software 2, instead you're building this bounding box and you're building this algorithm that it's not about like there's this idea of like missing the forest for the trees. You're just looking at the tree. You're not looking at the whole forest. Because you're so focused on the tree, right? So this is like a tree, and this is like a tree, these little dots here, and this at this endpoint, after the optimization, is just a tree. But it's really about the forest. And what the thing that you're doing in software 2.0 is you're not worried about the exact implementation and how it works and all of that. Instead, you're thinking about the process by which you got there, and by basically using that process and scaling up that process and iterating within that process, pushing that process forward, that is what gives you the result. It doesn't matter what that result specifically is. You don't care if there's a 1 or a 5 at this place in the neural net. It doesn't matter. It matters that you followed this process, and that's how you got to where you're going to go. And at the end of the day, like, this is also kind of like how a company works, because you're at a company and you have a team, and it's not, you might have an idea, you might have a conception about what is your product going to look like and what a customer is going to like and all of that kind of stuff. But when you really but really it's about what are your systems? How are you getting feedback from the customers and adjusting to the market dynamics? And like, how are you, like, basically, how are you operating in the market to get to product market fit? That's how companies work. So I want to dive into this idea a little bit. So this was an essay that I wrote back in 2021 about DAOs, and I'm not going to go through the whole thing right now, but essentially, there's this idea which is basically, I wish I had the video for this, but I actually quoted Sam Altman, of all people, in this, saying that, and when I transferred it over from my newsletter to this blog, I lost the link. But there was basically, Sam Altman was saying the rate of iteration is the number one determining factor for a company's success. And team goes in with some idea and they start trying to tackle a problem. And the rate at which they would try something and gather more information is and incorporate that into their plan and then adjust course if needed. Those number of steps of doing that was what basically built that's what led to people being successful, because they were able to gather more knowledge. They were able to get more information and adjust course whenever more rapidly. So, like, for example, like Jeff Bezos, he talks about this idea of one-way doors and two-way doors. So when you make a decision, basically what he thinks is, if it's something that you can reverse, like it's a reversible decision, which he calls a two-way door. If it's something that you can decide and then you can go back on later, you should just make that decision quickly and you shouldn't think too much about it. Only if there's a critical decision that you cannot reverse, it's irreversible, only in that case should you take a lot of time to actually consider the evidence and deliberate about it and have a lot of meetings and think about it, and basically drag your feet until you're sure that you know what to do. But the reason that with these two-way doors, the reason you want to go through them quickly is because if you're basically gathering information and making decisions quickly, you can try something. If it doesn't work, you go back through that door and try something else, and you take that information with you. And so, like every time you do that, you're learning, and you're able to incorporate that into your company going forward so that you don't make those same mistakes again, and you incorporate that knowledge into the corpus of your institutional knowledge. And like another thing is, like, when you try something, like sometimes these things can have a huge payoff. Like, for example, like I run a company, it's Chopin Framework. You can go check out, link in my X bio. And so if somebody watches the stream, I'm just trying this out. If somebody watches the stream, maybe they could be a customer, right? Maybe I could do a stream, it could go viral. A lot of people could watch it, they could come, and it could be, and then they can become a customer of mine, right? So that could pay off. And if you're trying lots of different things, you're going to sometimes hit it big, and find something that has a huge asymmetric payoff. And that's essentially what venture is. And we've talked about this in previous episodes of the stream, talking about like how venture is basically a bunch of basically a stochastic method of displacing incumbents, where you take a lot of small teams with a low probability of success, but you fund them so that they have a chance of basically brute forcing an innovative solution and doing something that a large corporation never could. So anyway, I visualize this as, like, imagine you're basically compounding your progress every time you try something, because you can take that information, you're where you were in the past, but you're also able to take that information and apply it towards like the future. So you learn from this experiment, and now you can take that and move it forward and into your next experiment. And so there's always some compounding benefit every time you've tried something or got some feedback or talked to a customer or did any sort of action. And so the quicker you're able to do these things and run these mini experiments, some of which could have asymmetric payoffs and all of which will probably give you valuable information, the quicker the rate you're able to do this, even if you're just getting a marginal benefit, if you do this many times, I mean, this is what's 1.1 to the third. It would be, I guess, like, I don't know, 1.33, right? But if you are able to do it twice as fast, this is 6 iterations, and each time you're compounding at that same rate, now instead of 66%, you're getting plus 77%. So this is, you did double the iterations, but you got more than double the payoff for having iterated faster. So it's basically, like, as you can kind of see, like, this is, in a sense, like, actually, I'd like to go back to this because now I'm kind of seeing this connection here. Like, you get this kind of a curve where the more you're able to iterate, it has this exponential payoff. You're not able to even approach doing these things by hand, let alone iterate and try something new. But as you're throwing more compute and data and designing less, you're able to make more and more adjustments. And even though like one round of backpropagation in a neural network is very inefficient, and it's much more efficient to just write something by hand most of the time, when you're just doing that so freaking much, you're doing so much training, it far outpaces what you could ever do by hand. And so the point that I make in this article, which I won't fully go into, is basically that companies hit a bottleneck. And the bottleneck decisions with it's like a zero-sum thing. You have a certain amount of resources that are internal to the company, and you are basically having to centrally plan how you allocate those resources within the company. So I've always been a firm believer in the power of markets. I think markets are very powerful, decentralized calculation mechanisms. And so I've always been against central planning. I think central planning doesn't work. There's lots of examples of central planning in the government where it's led to a disaster, or like where they should build factories, and it led to very inefficient manufacturing routes, like routing goods between factories because they put them too far apart, or they put two things close together where they shouldn't, or they would make way too many chairs and not enough nails. So they just have all these chairs sitting in a warehouse, but they don't have enough nails to build new buildings and stuff like that, right? Because it was just too hard for a central entity to calculate every single thing and incorporate all the knowledge that needs to be incorporated to manage the entire economy. And instead, a market does this in a decentralized way. And so that's why I've always been a fan of the free market over central planning. And this is something that I think at another time we can go deeper into. But basically, like I thought when I was writing this article, like, why does central plan, like, why do companies do central planning, but not why is that okay within a company but not within a government? Like, if we know it's not good when the government does it, so how is it good when the company does it? And the point and the reason is because of the corporate structure. It kind of has to be that way. And sometimes, you just have it's just things. There's like, you have one tractor in your corporation and you need to figure out how to use that. And so someone has to make that decision. So there's a sense in which the scarcity constrains what's possible, and it forces companies to act via central planning. And so basically the shareholders are central planners of the company, and this causes a bottleneck to the speed at which they can iterate. Because as they scale, they're able to iterate less past a certain point. They're first able to iterate more as they have more resources and more success, and then they hit bottlenecks where it becomes too hard to manage. And at some point they hit some sort of inflection point. And so it's not inflection point, but some sort of plateau. So I think that this is an important thing to understand. But I guess the reason why I bring this up is because when you talk about when you talk about AGI as an example, people talk about AGI and ASI, which is artificial superintelligence, which is supposedly more intelligent than humans. One common argument against people who are worried about ASI is that we already have ASIs. And these ASIs are corporations or governments or nonprofits or groups of people. Groups of people actually have more intelligence than individual people. Now, you can go back and debate this. I'm not trying to make that point within that debate. But I think it is a very valid way of thinking about it, because in a sense, like a corporation or even an individual is an optimizer. Like within the, and I'm not talking about within their brain, like doing optimizations in the neural network of their brain. I'm talking about the process that a company goes through is an optimization process. Like, let's go back to this image. Let's go back to this image that Andrej Karpathy was showing. Wait, where was it? I think it's over here. Let's go back to this image. Like, when you found a company, you're starting here. You had some idea. You want to make Uber for dogs. You're starting here. But then you realize nobody wants Uber for dogs. They want Uber for cats. And then you realize, actually, they don't want Uber for cats. They want regular Uber, except decentralized. And then you realize you don't want it to be decentralized. Like, you get the point, right? You start shifting the idea and you're searching. And if you have, as Sam Altman said, iteration speed is the #1 predictor of success in a company. If you are able to iterate fast, you're going to be able to gather information and find the and eventually you're going to find a really great company. Now, there's reasons why people, even if they are good at iterating, there's reasons why they don't necessarily succeed. But that's just because they don't fundamentally have enough time, because there's constraints. Like, you need to, pay. It costs money, and you have to have the willpower to continue working at a company. So even if you are iterating fast, and let's say you get unlucky, you might not be successful, because eventually your company's going to run out of money. Eventually you're going to lose the will to keep working on it. So it doesn't mean that everyone who iterates is necessarily going to be successful. But what I would say is, in that analogy, that would be similar to basically running out of GPU credits. Maybe you've trained your neural network and you haven't run it long enough to find a good, a good result, but you're now out of credits, right? So the point is it's the same thing. This is equivalent. What people are doing is they are searching for a product, and there's a criteria upon which they're optimizing. They're optimizing for profit. In a market, people are optimizing for profit. They're maximizing profit. They're doing like a gradient descent on profit, essentially, except it's like a much more complicated algorithm than gradient descent. But so like normally, like let's say you just train a normal neural network, you're going to be doing gradient descent, meaning there's going to be some prediction error. Like the neural network will think this is a cat, but it's actually a dog. It's going to be wrong. And it can be like very wrong or slightly wrong. Like you could think it's a tree. It's really wrong. It's not, it's a cat. It's kind of like a dog, but a tree is like very different than a dog, right? So there's, based off of like the error, what you're trying to do is you're trying to minimize that error. And there's a way of quantifying the error. And then you want to minimize the error. And that's gradient descent and backpropagation. We talked about that in the last episode. Not important though for this. The point is that what you're doing in a market is you are doing this. This is your path. You're going back and forth, changing what you're doing. Like when I founded Modular Cloud, we were making the Block Explorer. We were making cloud services for data retrieval for rollups. And over time, now we have an application framework for building apps using Web 2 technology that has the security of Web 3 using rollup architecture. It's a completely different thing. And so much had adjusted along the way. And the lessons learned from the past thing fed into the current thing. And so this really is truly the path of running a company. This is a really important thing to understand when you're understanding the connection between crypto and AI. So I want to tie it in. But first, before I really start showing examples of this in crypto, I want to kind of just lay a few more analogies between the crypto space and the AI space. So I want to kind of go into the history. So first of all, like AI has been around for a long time. Um, let me show you this. So like I think here I'm on Wikipedia now. So we're talking about the 40s, the 1940s is when people were first talking about these types of ideas. And cryptography is very old, but I do think that blockchain slash crypto is deeply intertwined and related to cryptography itself as a discipline. It's like an extension, but it's also a very different thing. It's like a next generation version built on top of traditional cryptography. I think cryptocurrency and blockchain, it does stand on the shoulders of those giants, but it is a categorically different thing in a sense. And people have been thinking about AI since the 40s. Like the cypherpunk ethos, which is what fueled Bitcoin and Ethereum and all of these things, that was like the 80s and 90s by the time that people were even talking about that, let alone actually doing anything interesting along those lines. Bitcoin was invented in 2009. This, like AI, like there's early successes in AI in the 50s. Okay, so when people are saying, "Oh, pivot from crypto to AI," these are not comparable in any sense. This is a much older thing with much less success, actually. So this stuff that you would look at early AI, this is not neural networks. I mean, neural networks were pretty early on. Like, so we have this Perceptron's famous paper. I think it's Perceptron. I never read it, but this is in the 60s, I suppose. I'm going to show you a really cool example of this in the 80s. But there's also these AI winters. So there's this AI winter, and then from 1974 to 1980, and so they basically had some basic success in the 50s and up to the 70s, like the late 50s to the mid 70s. So that's like 15 years of success. But this was 7 years, a 7-year boom. Like that's nothing. And then there was another winter, meaning basically no progress was made. Like the industry, nothing interesting happened. It was basically a dead industry with making no progress. Up until what I think I've seen different numbers on the estimate. Some people say this was in 2022 or 2020 when things really started taking off. But either way, we are in this new AI boom right now that's very, very new. And so there's been very few years of success altogether in AI. To run through this again, like people started thinking about it. I mean, you can go back in history and do these stupid things that they say, oh, this philosopher in Greece said this is artificial and intelligent. People, said stupid stuff that somehow is related. People like to tie in this grand narrative of the thought of intelligence means something historically, and now today we're realizing that whatever, forget about that stuff. I'm talking about real, like the real world. In the real world, people started really talking about this in the 40s, but they were just talking, basically doing nothing. There was some basic thing that was kind of like AI, and they did think about neural networks to some extent, although not deep neural networks, and it was just like this idea of a perceptron and stuff. They did some stuff that honestly sucked in the 50s to 70s. It was whatever, it was almost irrelevant. And then nothing happened for decades. And then for 7 years, they had a few cool examples of the use of the technology. And then again, nothing happened. for a long time, and now there's another boom. And when I say nothing happened, especially towards the end of this era, like this big data, deep learning era, I mean, there was interesting stuff. I mean, voice recognition was cool. I mean, it wasn't very good for the longest time, but at least it kind of worked. Fraud detection was really important. That's kind of AI. And handwriting detection helped the post office. Stuff like that. Recommendations, you got a better recommendation on certain social networks that used AI than you otherwise would. Like, there were things that definitely used AI, but this was not game changing. But the thing I want you to realize is that AI is mostly has been a flop. Right? Don't get me wrong, it's incredible. It's so cool. But mostly it's been, like, for most of the time, there's been nothing interesting there. And I'm not saying conceptually nothing interesting, but in terms of results, there's not been really any good results. So when you look and say, like, look how useful AI is, look how much value it's adding, and then you compare it to crypto and you say, oh, well, crypto has these problems, it's not that much has happened. Actually, a lot has happened in crypto, and it is very young. I mean, Bitcoin, again, as I said, 2009, that's when it started. And a lot of things have started since then and have already been extremely impactful in the world. So that's the first thing I wanted to point out. Now, I want to show you, just because it's interesting and fun, I want to react to this other video of a self-driving car from the 80s. And I've somehow seen, I think, a better video of this, but I didn't want to spend a lot of time researching where to watch these videos. But basically, Carnegie Mellon had a self-driving truck, and this is the reason why it's a truck is because they needed to fit the computers in it. It's not just they just chose a truck, like they actually, this was housing the computer. I just want to watch this 2-minute video and show you. Basically, they were hard coding it. They had this edge detection software based on like contrast, and they somehow were able to use that to guide it in the lane. I don't know the implementation details. It's a pretty famous example. A lot of machine learning, intro machine learning courses cover this, but I just thought it's 2 minutes. Let's just watch this. Let's see what people were doing in the 80s with machine learning and AI.
They built the NavLab, a test bed for research in robot navigation, image understanding, and the role of human interaction with intelligent systems.
You see the car is slowly moving. So that's, presumably it's driving itself. They're just going slow, obviously, for safety reasons.
The NavLab is a roadworthy truck, modified so that researchers or computers can control the vehicle as occasion demands. Because it is self-contained, the NavLab is not subject to telemetry bottlenecks, communication faults, or dependence on stationary infrastructure, and can travel to confront navigation problems at a test site. Driver controls allow a human monitor to override automatic control for overland travel, setup, and recovery from experimental errors. The NavLab shell houses all onboard equipment, including computers, controllers, telemetry, and internal sensors. In addition, it provides a working area for operators and allows researchers to gather data within the confines of the vehicle. Researchers can monitor and supervise the NavLab from the operator's console for setup, error recovery, and tuning. The NavLab supports a choice of sensing to accommodate many types of navigation research. Video cameras provide color and intensity images for scene interpretation. Road edges, for example, are analyzed through intensity, texture, and color segmentation. A scanning rangefinder sweeps the surroundings with a distance-measuring laser that provides useful three-dimensional information about the geometry and reflectivity of the environment. Taken together, color, intensity, range, and reflectance data provide a rich basis for building natural scene descriptions. Sensor information from several sources can be fused to achieve more robust perception. A Blackboard computer architecture integrates the distributed processes that sense, map, plan, and drive.
So, I mean, basically, they were able...
Let's not...
Sorry. They were able to...
We have recently built the NavLab.
Let me pause this. They were able to do really cool demos in the 80s. And so now you think about crypto, think about the promise of this, the promise of that. This project didn't work out, that project didn't work out. There's scams, there's all these things that might get you discouraged about the crypto industry. And there's how are we going to scale these things? There's all these challenges, and there's these roll-ups, and some of the roll-ups they're not really secure. And there's just so many issues in the crypto industry. Like, don't get me wrong, but like, let's have a little bit of perspective here. This was a self-driving car, a proof of concept, a demo in the 80s. And we barely have that today. I mean, we do have that. Like, Tesla is very good, and I've said that like 50 times, but Tesla is very good at self-driving today. But if Elon Musk didn't exist, for example, nobody would have solved this. And yet, it would be coming soon still, but nobody would have. So how long does that take? It's okay to be an industry in its infancy. Are we gonna, for example, blockchains are not private. Like, almost nothing is private. There's a few things private. There's proof of concepts of things that are private. There's a lot of security holes in a lot of prominent protocols, but we know how to fix it. In this case, right? They didn't even really know how to build a self-driving car. This was the completely wrong way of doing it, and I don't know about their implementation much by hand, edge detection, just trying to find where the edge of the road is and then accelerate and stay in the middle. Something that's very simple, which is still cool, but this is the proof of concept of that. And it took this long to have any fruition. And basically the whole industry had nothing going on. It was like a bunch of bullshit scams for decades. And now look at it. It's amazing. It's the most amazing thing. And us as an industry, we have the crypto industry, we've made a ton of progress. There's a lot of really cool things that you can use today, a lot of really cool protocols. And we also have the roadmaps to fix all the problems almost that we're dealing with. And so, I just think that it's good to go easy on the crypto ecosystem. I think we should always hold people to a high standard, call out bad actors, push people to be the best version of themselves. And I'm actually a very critical person of crypto because I love crypto and I love the people and I want them to succeed. So that's why if you love someone, you're critical. And that's also why I'm critical. I'm going to be very critical of AI. Actually, I'm going to go completely savage on these AI people in just a second and diss them. But that's because I think that they are doing the coolest thing in the world. I mean, my enthusiasm for AI is through the roof. And I think it's a fascinating subject. But that's why I'm going to be hard on them. So, okay, let's talk about this. I'm going to pull up a tweet. So I don't want to call people out by name, because I think that first of all, I'm just not so informed that I believe I should be doing that. But second of all, I just don't want to single anybody out because this was a systemic problem. But look at this, and look, I understand venture. So a lot of businesses get funded and fail in venture. That's so common. There's no shame in that. There's no shame in that. So I'm not trying to bash founders or people that are innovating or trying anything. But let's just look at this because I'm trying to communicate to people who maybe weren't paying attention or weren't old enough to know at the time what this was like. So here are some examples. Cruise was Y Combinator's biggest exit ever at the time. I think they got acquired it was in the billions of valuation, and by GM, and it's a self-driving car company. Well, they shut their doors, and George Hotz, who's a total badass, he criticized them for a long time. And he's writing this, and he's definitely an authoritative source on self-driving. He's the founder of Comma AI and TinyGrad. But he's also pointing out Ghost Autonomy raised $240 million, Argo raised $3.7 billion, and they're worth zero. And this, I don't have all the receipts. Okay, so you're gonna have to take my word for it. But AI back in 2010 and when kind of these companies were founded was a scam technology. It was the kind of thing where you say it's this plus AI, just like you'd say it's this plus blockchain, it's this with a token, it's this with an NFT, and how you might think that that is very highly correlated with scams. Well, AI was a scam. People would do AI and they would say, oh, my company sucks now, but AI is going to get better, and then that's going to save it. I'm not trying to make this is not personal, and I could be completely wrong, so I just want to be a disclaimer. But like XAI, Elon's company, the domain XAI was originally, and it would be like an AI assistant that would help you schedule things. And the idea was, as AI got better, then it would, be able to do a really good job of being basically like your secretary. I might be misrepresenting this, so just take this with a grain of salt. I'm just trying to give you some examples so you can understand what happened. Well, basically that company, it was a moderate success. It wasn't really successful. I had a friend who used it. I didn't think it was very good. They ultimately got acquired, and then what I think was basically not a very successful acquisition. But some of their scheduling software was internally useful for some company you haven't heard of, and that's what it was. And there's no shame in that. Please, like honestly, super cool. Like the name XAI is super cool. Like the guy got an X, it's super hard. I'm not trying to bash it, but I'm trying to illustrate an example of the kind of thinking of just make this product, and then eventually AI will make it so good. As long as you're in there, AI is going to then take it to the next level when it's ready, and then it's going to be a very good idea. Now you can think of it's a great idea. It's like a secretary that's actually an LLM. I think there's lots of companies doing this. XAI was ahead of its time, so you have to give them props for that. But the thing is, though, is that if you have the wrong timing, that you're still wrong. So timing is very important. You have to do things at the right time. The technology was not ready at that time. And so, of course, then Elon goes and buys X.AI for his company, which is super cool, super amazing company. So what I'm trying to get at is not to paint anybody like that with a bad brush, but it was a thing where there were a lot of bad apples. A lot of people would claim AI, and they would use that to hype up their company, and they would use that as an excuse for not figuring out a good business model in 2015 or 2010 or whenever they were doing that. They would say before that there was big data. They would say everything's big data. You have big data, like that data set's like going to be oil. Like you can do all this stuff with it. This was a bunch of, there was some good stuff there, but mostly it was so much less important than it is today. Now AI is revolutionary. Objectively, it's going to displace people's jobs. It's going to forever alter the way everyone retrieves information, everyone works, everyone does everything. But back then it was like, oh, here's a better Amazon cart suggestion. Like it was lame as fuck. It was not cool. And okay, and now I'm going to go. What is that? What is that phrase? I don't know. Whatever. I'm going to just destroy AI people right now. Okay. These people, like a lot of the people who were in AI were basically these like kind of loser ideologues who thought that there was going to be this AI takeoff and AGI, and these people that AI was going to take over the world. And they were caught on this sci-fi fantasy that basically was just all fiction. But they were obsessed with that, and that was the majority of the people who went into AI. And so these people basically LARPed as being important and LARPed as revolutionaries. They were not. So this is why, like just go and like look at like Anthropic, and like just listen to the founder, his conversation with Lex Friedman. He'll be talking about AI safety and all this stuff, and like how they're like trying to figure out alignment and all this stuff. This is so dumb. This is all so dumb. This is basically, and I'm not trying to bash them personally. This is a thing that the whole AI industry did. They were obsessed with this narrative, and so you think, oh wow, these people, they must know something about AI that other people don't know. So when they're concerned about AI taking over the world, I should be concerned too. When they think that alignment is a very serious problem, I should also think it's a serious problem because these are the experts, and look at the amazing thing that these people brought to us. Well, now let's go back in the history. If you go back, let's go back to Wikipedia here. What are some of these early predictions? I'm sure that people have used this talking point a lot. Let's see. Oh, here we go. Optimism. People had said within a generation, the problem of creating artificial intelligence will be solved. From 3 to 8 years, machines will have we will have machines with general intelligence of an average human being. All this stuff in the 70s, in the 50s, they weren't even on the right track. They weren't even close. And people have been saying that. And basically, these people worked on this problem. They didn't make any progress. They barely did anything. There was winters after winters. Then we finally got some marginally useful things. And it's not everybody, but come on. And then basically the people who were interested in this were the people who watched sci-fi or read sci-fi and got into this idea of a fast takeoff AI future. And this is not where the talented people went in tech. This is not where the smartest minds were thinking about. This was people who were just kind of in a fantasy land and basically not accomplishing anything. But they did make some progress. But what really happened is that Moore's law continued and GPUs got really good. And they were not in control of that. And they had no idea what time scale that would happen. What time scale would Moore's law deliver? Like, you could predict computer scaling, but you wouldn't be able to predict at what threshold you needed to have an interesting AI system. And so, I mean, these people, they just got lucky, essentially. They were interested in this topic, and they have this obscure interest in this doom scenario thing. And a lot of them, they have these conceptions of like extreme self-importance, like that this is like existential for humanity to solve this problem, this science fiction problem. And essentially, that's why they talk about this stuff. So they spend a lot of time trying to be political, trying to make this a more philosophical thing than it really is. And they think about adversarial environments and like, how do you like destroy the data center? What if the AI gets out? Do you like bomb the data center? Like, what if a nation state does this? How is this going to affect national security? They think about all this stuff. And that's because that's what they already did. That's the only reason they happen to be the leaders in AI in the first place, because they already thought like that. And they basically made very little progress. And then basically Taiwan and the Netherlands and Jensen made really good chips. And then all of a sudden, the stuff that they did, which was good work, the stuff that they did ended up actually having a good result. But it wasn't because of anything they did. And so you got to take what they say with a grain of salt. And you kind of got to see that a lot of these people are just not that, you just don't need, they're not anything special. They're not someone that you need to like heed their warnings or heed their advice or put them on a pedestal. Remember, it's about the system that created things. It's not about the exact. Bezos referenced one of the ideas earlier in the stream. I referenced the idea of like one-way doors and two-way doors and decision making, and it's very true. So there's a lot to learn from Amazon, but I would caution someone from trying to emulate Amazon too closely or studying it too much. Don't spend too much time doing that. And the reason is because Amazon is one of the biggest companies in the world. It's a great company, but the reason it's successful is not because of what they did themselves. It's about the context of the market in which they operated. And the market, as we were discussing earlier, it's a giant search mechanism. And there are different optimizers in this market searching for product market fit. They're searching for business models that maximize profit. And so the market is a meta structure, and the people that are in the market are, in a sense, they're getting lucky. And you can attribute success to people who keep defying expectations. You can attribute competency, I mean. So like Elon, he's made all these companies. You have to hand it to him. You have to. And he is clearly exceptional. And Jeff Bezos, clearly exceptional because of he kept elevating Amazon, kept winning, kept doing countless impressive things, even within the same company. So you have to hand it to people who are consideration. And it's hard to disentangle which particular things actually made the difference versus what is just noise. Like someone may have written a memo instead of a PowerPoint, but was that really impactful? You definitely see the impact when you look at what is happening within Amazon. You see, oh, people are reading these memos or making good decisions, but is that really why? Or is there some other thing that's causing them to make good decisions? And to disentangle that in such a complex system as the economy and like what has caused someone to succeed in a market is very, very difficult and practically impossible to understand. And that's because the market is a complex system. And a complex system is something that you cannot understand by just looking at a single component. It's too complex. You either don't have enough information or enough computational power or a variety of other, or enough know-how to evaluate it based off of that. And really, at best, what you can do is you can kind of just look at the macro behavior of the market. And by looking at the macro behavior of the market, you're able to you are able to make predictions, just like you may not be able to understand what's happening in someone's body just based off of looking at a single cell, but you could predict. But the point that I'm trying to make is just because we are in an AI boom, and then not thanks to the field, thanks to someone else, that it ended up being useful on a time scale that they were lucky to be a part of. And it was not due to an insight. And even if they said, oh, I thought this would happen, yeah, maybe they did, but they didn't actually know that. And there is a degree of luck into that. But that's how the economy works. And that's what's awesome. And that's part of the reason why central planning doesn't work, going back to what we were talking about. Because if you were to allocate people to work on the most important problems, if you were running the economy or you were running a company internal to the company, a lot of companies didn't bet enough on AI or progress in AI. And that's because they were trying to make the prudent decision with the company's resources. And there just was not evidence that AI was going to yield results. And you can say there was, but there really wasn't. It would have been a speculative venture. You would have been using the company's precious resources on something that was very speculative and might not have worked out. And so it was reasonable for incumbents to not invest in AI at the time. But what happened? It ended up being massive. And so but that's the beauty of it. So these people, these kind of crazy lunatics, they seemed dumb at the time, almost. I mean, you knew they were smart, but they seemed crazy. They were like outcasts, but they happened to, there happened to be a tail event, and they were way out there, and then they got a huge payoff, and they happened to be on the right tail, and they happened to have like a huge, massive windfall, and now they're running the most important companies in the world. And let's see how kind of person who likes to say, but I like to just be hard on people, and I like to kind of point this out. So AI, my point though, is that AI has not really done anything better than crypto. Crypto has actually been a way more successful industry, starting a lot sooner. And, in many ways, crypto does all the things that AI people dream about. Like, they have this idea of this self-importance of like that they, it's important for national security, and we need to figure out alignment and adversaries and all of these things. And that's what that's what crypto deals with. Like, crypto actually is a politically significant technology that is built for adversarial environments that has implications on everything. And it's just interesting that AI founders have basically worked at universities in the ivory tower and got funded sometimes with billions of dollars, and at this point, now they have national security advisors on their board, and the most important people in the world are on their board, and these companies, they have safety departments and all this stuff. And crypto founders have been through really hard times. They've been prosecuted, they've been sanctioned, they've been, they've just been relentlessly attacked. And so whatever. It's honestly not a good thing. I'm not endorsing any of this, like anything that crypto people have done that's been illegal. There has been a persecution of people in crypto, but it's just funny because that is almost what and there's a lot of scammers, there's a lot of bad actors, but there's also a lot of badasses who have been hardened in not only have they delivered a lot of value, but they've also been through a lot and they understand how the world works. So I couldn't be more bullish on crypto. And so what I want to kind of close out this with is I want to talk about how crypto is software too. Because remember, we're talking about, if we go back here, like AI, and so you're minimizing the error in your neural network. And corporations there's also a search process. It's this iteration process. You could use the same exact image here to look for what you're optimizing. People have already made this comparison. I've actually made this analogy that a human is almost like a neural engine. Like your phone has a neural engine. Humans are like a neural engine. They have a processing power, and they can actually they can run inference, and they can think and search for a problem. They can search for a solution to a problem. They can try things. And if you have multiple humans, that's actually like a multi-core processor. And if you communicate well between them, you can offload cognitive tasks and work together to achieve something that one human alone could not achieve. And it's really interesting when you think about the scaling of this. If you look at the scaling of distributed systems and these large scale computers, you see that there's bottlenecks that start to occur in terms of the bandwidth between the different nodes, and it's been a long time since I've studied that, but you can't just simply scale it up. There's a lot of considerations in terms of because as you basically make a bigger cluster, you run into all these different bottlenecks. And the same thing is for human organizations. You have a group of 5 friends. They could probably work very effectively together. They can talk and write things down and communicate and to basically distribute the cognitive load very effectively across the 5 different people, especially if they're familiar and they know how to talk to each other. They just have smooth communication and they're experienced in that way. They're going to be an absolutely killer team. But when you start going to 5,000 people, that's going to fall apart. They're not going to be able to maintain that. And at that point, it does hit a ceiling and a plateau. And then again, as we were talking about, a market then is the bounds on that. And that creates a system that will reward or punish the winning teams. And therefore it searches for the team. The market searches for the winning team that's actually providing the most value. And this is all measured based off of optimizing for profit. And there's just there's a beautiful mechanism in there for, with basically taking out the losers from the equation. So you're not expending resources on these losing teams. And then basically those become available to the winners. And then you keep rebalancing it. And that's what a market does. And so crypto does that too. Crypto is basically a way of building designer markets. So crypto provides these. There's Amazon and Google and whoever in this market. You actually you can actually make a market that could direct people and incentivize them within this smaller ecosystem. And it's part of the larger market. But you can kind of use these market mechanisms at a smaller scale, and you can program that. And that can actually, and there's a lot of things that could go into with how DAOs can do that, and they can scale bigger than corporations, which is work research I've done, but I'm not even trying to go there. The point is that that is what crypto essentially does, is by creating tokens, you're able to incentivize people to take certain actions and participate within a network to basically program a search function that will find the best organizational structure and use of the resources within the system. So let me give you a few examples of this. One example is Bitcoin mining. Bitcoin mining is a simple example where basically you have a log of historical transactions, but there's a lot of entropy because you don't know the ordering of that list. And you don't know the validity as a result, since you don't know the ordering. And so what Bitcoin mining does is through a mechanism of rewarding miners, they're actually able to make them run computations called mining that reduce the entropy by creating consensus in that system. And so you've now programmed incentives to get people to come into and join the system, and you've programmed them to then now achieve a goal. Another example is like another cool example is Celestia. So like think about BitTorrent. BitTorrent is a really cool information sharing protocol. It's no longer available. Or if too many people try to download it at once, there can be issues. There's all kinds of reasons why this data goes offline. Celestia has a way of actually ensuring that that data is going to have liveness, and they are able to incentivize people to seed that data so that data can be downloaded by anybody. That's a remarkable thing to have achieved. I mean, there's like prover networks are coming, and like that's going to be a really important thing, because not only would you be able to download data from Celestia, but you'd also be able to verify computations. There's going to be incentives that cause people to run computations that allow people to verify the results of other computations. That's going to be super cool. And there's a million examples. Intents. People are solving intents, so they're basically using intents and finding solutions that cater to the needs of different users, just based off of like what they want, so to speak. AMMs, like there's like arbitrage opportunities that basically make AMMs function and make prices consistent. So bottom line is that this is what crypto does, and it's a super powerful thing, and there's a lot that you can do with this. And I think that this is, even to an extent, a broader category than AI itself. Like AI is software 2.0 because you're searching for this, but crypto is also software 2.0 because you're not telling people what to do. You're just not a company. You're not instructing miners, you should mine something, you should run this algorithm. That's not what you're doing. You are incentivizing them, and they are doing it. You are just setting the parameters, and they are now in the architecture, and they are then running it themselves. They are choosing to do it because they have been incentivized by the designer market that you have created. And so this is super powerful. And you can see how this is like almost the parent of AI, because I think it's inevitable that AI runs on crypto rails video. But what I want to let me give you a few real examples of this. So several years ago, I think this was in 2021 or 2022, I'm not sure, probably 2020. Oh yeah, 2021. Sam Altman came out with this thing called Hyperscale DAO. And so he was interested in looking into DAOs. And so he just kind of tweeted about this, and then he posted the link to the Discord, and a lot of people went crazy. So I joined this. I ended up putting together this document, looking at everything he said in the Discord, and so I have all these quotes of things that he had said about what his thoughts were on this, and I compiled this into a Q&A, and I put sources. So yeah, so like basically, Sam was interested in the concept of DAOs, and this was in 2021. And he was interested in this, so he wasn't able to act. He thought it was basically too risky to do anything himself. And we have the source for this. Oh wait, hold on. No, that's the source of the Discord. Yeah, I'm not going to read all this, but there's a lot of evidence. You guys can come on, and if you look here, Sam Altman wanted to do an ICO, an initial coin offering for OpenAI, and Elon did not like that idea. So Sam himself, who also, by the way, was instrumental in getting WorldCoin up and going, which is an interesting project to discuss another time. But Sam was very interested in what crypto could do for AI. And think about how OpenAI was founded as a nonprofit. They felt that they needed a different corporate structure that was different from the standard Delaware C Corp. And of course, that did not work. They wanted to do a nonprofit, and they had this weird structure and these weird contracts, and that has just been a disaster. And they've now, I should have got a source for this, so I'm not going to pull it up, but everyone knows this, so you can look it up, or you can just know that this is true. They have been converting it to a for-profit because their experiment in the nonprofit world did not really work. But at the same time, they didn't think for-profit's a particularly good idea either. They didn't think for-profit is a good idea. They didn't think that nonprofit, they thought it could be okay. I don't think they thought it was ideal, but they thought it would be the best bet that they had for OpenAI. But at the end of the day, it didn't work. It was proven to be bad. So are those the only options, nonprofit and for-profit? Are those the only two possible ways that humans can organize? No. And Sam knows this, and he knew this. And he was clearly exploring what you could do with a token. He was clearly exploring the idea of DAO, but people pushed back at every step. Elon didn't want him to, but also it's just legally difficult. And then later on, he also thought he couldn't, for hyperscale, he thought he couldn't do it because it would be too risky. And he wasn't saying he'd make OpenAI a DAO at that point. I don't know what he was thinking. I think if OpenAI was a DAO, I don't know what that would look like. But that would be a very interesting possibility. And it basically, though, let's assume that there's some reason that crypto could have helped OpenAI have a better corporate structure and better incentives and better. And by the way, think about this. A lot of people are leaving OpenAI right now. Are they not adequately incentivized? I don't know if that's part of it. I don't know. Maybe not. I think a lot of people got good compensation, but perhaps there's more demand to pull people out of OpenAI than they feel that they are bought into its future success. But either way, if crypto can accelerate OpenAI as an organization, even conceptually, that shows that it has an important influence on how AI could be built and proliferate. And so let me see if I have any other notes here on this. Yeah, so aside from that, though, just to close this up, I think that there's going to be very interesting considerations on what people are doing with agents, with AI agents. There's going to be very interesting things there. Decentralized training network, how are we going to train things in the future? Who's going to own the models? How are we going to buy and sell data sets? How are we going to do all this stuff? How are we going to organize? How are we going to how are we going to, when someone contributes, to building an AI, how are we going to reward them for that? All these things can be accelerated by crypto. It's the ultimate meta layer for programming intelligent entities. And just like AI itself is an optimization, this is just an optimization that you can run an optimization inside of. That's what a market is. And we're able to program these run on crypto rails. And there's a lot of projects working on this right now. I think a lot of them are probably not going to succeed, but some of them might, or maybe none of them will. And maybe we're going to find, things that do a few, 5 years from now. Maybe it's too early, but we're going to see. And I think this is really interesting. And so, yeah, that's basically, that's my pitch. So I guess what I would say in the end is that Web 3 is software 2. With crypto, just like companies, just like markets, they're not something that is centrally, they're not something that you just know. And it's not something where you just know what the answer is. Like software, you just know what you need to build and you build it. But in crypto and markets and in companies, there's a search problem and you're searching for something, you're optimizing for something, and that's what AI does. All of these technologies do this. And crypto does this just as much as AI. And don't buy into the crypto FUD. Crypto is a super high performant industry with super cool founders. And I was having fun bashing AI founders, bashing the AI industry. I don't mean it. I really don't mean it. I'm joking. I think it's fun. And I only say that because I actually really like them and I want to push them. And I do think that AI doom is dumb. I don't believe in it. I think that all that thought thinking is completely wrong. And I'm going to do another video on that sometime. I'm debunking AI doom predictions. But yeah, I think this is a good place to wrap it up for today. We finished going through the Andrej Karpathy video, and we talked about the overlap of crypto and AI. And we had some fun banter.